guys, welcome back to my YouTube channel. So today I am going to solve day 25 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 912, sort an array. Okay, so in this problem we have given an array of integers nums, and we have to sort the array in ascending order and return it. Okay, so this is a nums array given to us, right? 5 2 3 1, and after sorting it is looking like this: 1 2 3 5. Okay, so you must solve this problem without using any built-in functions. Okay, in n log n time complexity and with the smallest space complexity possible. Okay, so we have to solve this problem in of n log n time complexity and with the smallest space complexity possible. Okay, so I hope that you guys are clear, okay, of what we need to do here in this problem. Okay, so now let's understand this with an example first. So let's take this array. So in my array, elements are like this: first element is 4, then after that 10, then after that 3, then after that 5 is there, and then after that 1 is there. Okay, so now first thing that we need to do here, so let's create the array representation. Okay, so this is nothing but this is array representation now. So using this array representation, I am going to create a binary tree first. Okay, so how we are going to create a binary tree? So it is going to look like this. So first 4 here. Okay, so this is how we fill the values in binary tree using the array representation. Okay, then after that I have to fill 10 and 3. So 10 comes here, then 3 comes here. Okay, then after that I have to fill 5 and 1. So 5 comes here, and then after that 1 is going to be here. Okay, so I have filled the values, okay, using this array in my binary tree. Okay, so now see here, if I just give this as my index number 0. Okay, so let me write it like this: 0, this is index 1, this is index 2, this is index 3, this is index 4. Okay, so this 4 is at index 0, this 10 is at index 1, this 3 is at index 2, this 5 is index 3, and 1 is index 4. Okay, so from here can I derive one formula? So if my left child, okay, so let's say if my root is at ith node, then my left child is going to be at this node, 2 into I plus 1, and my right child is going to be at this particular node, 2 into I plus 2. Okay, so let's see is this formula correct or not. So let's say right now I am at this particular root. Okay, so let's say my root is at this particular index. Okay, I is equal to 0. So see, is my left child is at this index 2 into I plus 1. So I is 0, 2 into 0 plus 1 is 1. So yes, my left child is at this position. Okay, and my right child, let's see my right child. So right child is 2 into I plus 2, 2 into 0 plus 2, so 2. So 2 index value is 3. So yes, this 3 is the right child of this 4. Okay, so this is correct. Now, so let's say this is my root now. Okay, this is my root. So my root is at index 1. Okay, so now my left child. So for this 10, I have to find my left child. Okay, so here I am going to write 2 into 1 plus 1. So that is nothing but 2 plus 1 is equal to 3. So 3 is simply means 5. So 5 is the left child of this 10. Okay, so this formula is correct. Now I have to find the right child of this 10. So 2 into I plus 1 plus 2. Okay, so for right child I have to write like this now: 2 into I is 1. Okay, for root plus 2. So 2 plus 2 is 4. So for this 10, I am saying that at 4th index I have the right child of this one. So yes, so see, this value is 1 and this one is the right child of this 10. Okay, so this is correct. So I hope that this is clear, okay, how we are going to find the left child and right child, okay, for a particular root. So initially I am starting from this 4, right? So now after that, what we have to do? So we have to build the max heap. Okay, because okay, I will explain later. why we solving this problem using MaxHeap. But we'll first see what we are going to do here. Okay, so we have to start heapifying from the last known leaf node, which is nothing but n divided by 2 minus 1. So here, what is the total size here? Total size of this array is 5. So if I just do 5 divided by 2 minus 1, so what is the result that I'm going to get? So I'm going to get my result as 1. Okay, so now at this index number 1, 10 is there. Okay, so 10 is nothing but my last known leaf node. Okay, my last known leaf node. Okay, so first thing is that my heap is a complete binary tree. Okay, so every full binary tree is going to be complete binary tree, and every heap should be complete binary tree. Okay, so here see how we fill the values in our heap. Okay, so first let's say complete binary tree. Okay, so first we have to fill this node, then 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 we have to fill this node. Okay, so step by step we need to fill all the values, right? Step by step. So if we miss anything, okay, so let's suppose that I missed this part, I missed this one, and I directly filled these two. Okay, then it is not a complete binary tree. Okay, then it is not a complete binary tree, and if it is not a complete binary tree, then definitely it's not a heap. Okay, so I hope that this line is clear. Okay, so now let's see what we need to do here. Okay, so first this we have to start heapifying from the last known leaf node, which is n divided by 2 minus 1. Okay, so that means this one. Okay, so now what we need to do here, we have to compare these two first. Okay, so my left child is at index 3 and my right child is at index 1. Okay, so here compare these two. Okay, so 5 and 1. Okay, so which is larger? So 5 is larger. Okay, so we have to create first a max heap. Okay, so now how we need to create a max heap? Okay, so what is max heap first? Okay, so in my max heap, so let's say if this value is 40, then the left and right child of this 40 should be smaller than this parent. Okay, so it should be, I can give it 20, or I can give it here 30. Okay, then for 20 I have to give values like this. So this is my parent now, so for the child of this parent, so I can give values like this 5 or 20 here. Okay, so values can be same. Okay, but it should not be greater than the parent. Okay, so child value should not be greater than parent. Okay, same way for 30, so I have to give here value smaller than 30 or equal to 30. Okay, I can give, I can write 30 or 15. Okay, so this is nothing but my max heap. Okay, so in my max heap, always the maximum value will come at this place. Okay, root. So root will have maximum value in my max heap. Okay, so now we have to create a max heap for this one. Okay, so 4, 10, 5, 1 and 3. Okay, so let's do that now. 4, after 4 we have 10, and here 4, 10, 3, 5, 1. Okay, 4, 10, 3, and then we have 5, then we have 1. Okay, so now what I'm going to do, I'm going to compare these two. So 5 is greater, then I have to compare this 5 with 10. Okay, so 10 is greater, so okay, so no need to change. Okay, so that's it. So this is going to be step 1. Okay, so there is no change in my tree. Now after that, I did for index, this index, particular index 1. Okay, so now I have to do for this index number 0. Okay, so now I reach to index 0 and my index 0 value is 4. Okay, so for 4 now I need to check. Okay, so see here for 4, so the left child of 4 value is 10. Okay, the left child of 4 is 10 and the right child of this 4 is 3. Okay, so now which value is greater among these childs? So 10 is greater, so now I have to compare this 10 with the 4. Okay, so which value is greater? So this 10 is greater than this 4. So now what I'm going to do here, so let me just create the nodes first. So this and this. Okay, and here let me draw this array as well. So this is how it looks like, right? In the starting 4, then we have 10, then we have 3, then we have 5, then we have 1. Okay, so now I am going to replace this 10 with 4. Okay, so here my 10 will go at this place and my 4 will go down, and 3 is here and 5 is here. Okay, 5 is here and 1 is here. Okay, so now what I did, here, so let's see, this is my index 0, this is index 1, this is index 2, this is index 3, this is index 4. Okay, so I have just swapped these two values, right? So now my 4 is going to at this position and my 10 is coming to this position. Okay, because my 10 is greater than this 4, right? So I have just swapped it. Okay, so now let's me change it. So here I'm going to write 10 and here I'm going to write 4. Okay, so see, it is correct only. So 10, then 4, then 3, then 5, then 1. But is it a max heap? No, it is not a max heap. So see here, this value is 4 and just compare the childs of this 4 now, 5 and 1. So which is greater? 5 is greater between them, and 5 is also greater than the parent. Okay, so this is not a max heap. So now what I need to do, I need to swap the positions of this one. Okay, so 5 is going to move to this 4. Okay, and 4 is coming to this position. Okay, so now let's swap that. So this is going to be my next step. Okay, so now let me remove it. So it will become 5 and it will become 4. Okay, so now see, this is a max heap, right? So for 10 values are 5 and 3, which are smaller than 10. For 5 values are 4 and 1, and these both are smaller than 5. So yes. Okay, so here let's swap the values here as well. So here this will become 5, this will become 5, and this will become 4. Okay, this is done. 10, 5, 3, 4, 1. Okay, so now once this is done, so now check, this is a heap. First let's check if this is a heap. Yes, this is a heap. Why? Because see, this node is filled, then this is filled, then this is filled, then this is filled. Okay, these two are empty, no need. Okay, so all the values from starting to end are filled. Okay, so that is why it is a complete binary tree. So if it is a complete binary tree, then definitely it means that it is a heap. Okay, and now see, the root has value greater than its child every time, so it is a max heap as well. Okay, so now let me explain a little bit more. Okay, what is complete binary tree and what is not complete binary tree. Okay, so I have already explained here, I think somewhere, yeah, this one. Okay, these two are empty. So if I just do the array representation of this one, then how it is going to look like. So let's say this node value is A, this node value is B, this node value is C, this node value is D, this node value is E. Okay, so here if I just fill them here, A will come here, B will come here, then C will come here, then here null will come. Okay, this is null, this is null, and this is D, and this is E. Okay, so now if I do the indexing of this one, then you will find that this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5, and this is 6. Okay, so see, B is left children, so 2 into 1 plus 1, so it is 3. So see, null is there. B is right child, 2 into 1 plus 2 is equal to 4 index, that is null. Okay, so it is correct. So a tree is not a complete binary tree if from starting to end in the array representation, if there is any value null. Okay, then it is not a complete binary tree. So here, see here, in between null is there, but here in this my array, all the values are completely filled from starting to end. Okay, after this, if it is null, then no need to worry. Okay, but in between it should not be null. Okay, so that is why it is complete binary tree, and that is why it is a heap. And since the root values are always greater than the child nodes, so it is a max heap. Okay, so this is done. So this is first step. Okay, now we move to the next step, what we need to do. Okay, so now my array is going to look like this: 10, 5, 3, 4, 1. Okay, now we have to move to the second step. Okay, so second step is simply means sorting the array. Okay, so for this building the max heap, it is going to take the time complexity as of n log n. Okay, n of log n. So this is the time complexity for the heap. Okay, so this is done. Now after that we have to sort the array. Okay, so now what we need to do here, we have to heapify the root for size 4. Okay, so first what we are going to do, so let's see. So if I just do the diagram for this one, 10, 5, 3, 4, 1. Okay, so this is one array representation, or now I'm going to make the diagram of this one. Okay, so this is nothing but my max heap now. So I'm creating a diagram for my max heap. 10, after that 5, after that I have to fill this node, 3. After that I have to fill this node, so this node value is 4, and after that I have to fill this node. Okay, this node value is 1. Okay, and these two are null. Okay, no need. Now what I need to do, now after that, this is my array. Okay, this is my array. Okay, so this is index number 0, this is index number 1, this is index number 2, this is index number 3, and this is index number 4. Now what I need to do here, I have to delete the element from heap. Okay, so every time whenever we are going to delete the element from our heap, we should always delete the root element. Okay, we should always delete the root element. Okay, so now how we are going to do this? Okay, how we are going to do this? Okay, so now let's understand. So here, to delete the element in our heap, what we need to do? Okay, so one thing here, if I delete this element, then my heap size will remain 4. Okay, so let me do here break this. Okay, so now my heap size will remain 4, right? So this size is 4 now, this part. Okay, so this is one thing. So now what I'm going to do here, I am going to delete this 10. So let's say I am writing 10 here. Okay, I have to delete this. Okay, this is done. Then after that, what I need to do here, I have to bring the last element. Okay, what is the last element from my heap? Okay, so last element is 1. Okay, so see the last element is 1 here. Okay, last element is 1 here. So I have to bring this one at this position. Okay, I have to bring this one at this position. Okay, and then just write all the remaining elements as it is, 5, 3, 4. Okay, so this is what we need to do here. Okay, so now after bringing this one here, now what will happen? So here let me do the diagram of this one. 1, 5, then 3, and then 4 here. Okay, 4 here, and I have deleted this one. Okay, I bring it here. Okay, and now after that I have to check if it is a max heap or not. It is not a max heap. See here, between 5 and 3, which value is greater? 5 is greater, and then we have to check 5, compare 5 and 1. So both will swap. Okay, both will swap now. Okay, so now my 5 is going to come at this position. Okay, at index 0. So here I am going to change, here I am going to write 5. Okay, so here let's see here, so here I am going to write 5, and then my 1 will come to the 1 position. Okay, this one. So here I am going to write 1. Okay, so this is done. So here also we need, let me change. So here 5, and here in the next position it will be 1. Okay, this is done. Okay, now again check 1 and 4. So 1 is the parent and child of this 1 is 4. Okay, so again we need to swap. Okay, so now in place of 1, 4 will come. So here see in array I am changing it to 4, and here I need to change it to 1. Okay, 5, 4, 3, 1. So here again in the diagram also, here this will become 4, and this one below 1, this will become 1. Okay, so now this is a max heap, right? So this is max heap. Okay, so this is done. And what was the element that we have eliminated? This 10. So this is one empty space now. This is one empty space. Okay, in my heap this is one empty space. So what I'm going to do, I'm going to insert this 10 here. Okay, in my empty space. Okay, this is done. Okay, this is done. Now this is my root. Okay, this is my root, and always whenever I'm going to delete the element from heap, it will always be my root. Okay, so now how we are going to delete the elements in my heap? So simply we need to bring the last element. Okay, this last element. Okay, so first thing is that I have to delete this 5. Okay, so here let me draw this. So now I have to delete this 5. Okay, so let's say I have removed this 5. Okay, I have removed this 5. So 5 is here, I have removed. Now in this 5 I have to bring the last element again. So now I bring 1 here. Okay, then all other things we have to write same, 4 and 3. Okay, so let me create the diagram again. Okay, so this is the diagram, and these are the indexes 0, 1, 2, 3 and 4. Okay, these are the indexes. Now after removing this 5, my heap size will be 3 now. So here let me create breaks. Okay, so now these two are the empty spaces. Okay, these two are the empty spaces. Now what I'm saying, I am saying that after removing 5, just bring the last element to this 0th index. Okay, so here I am bringing 1. So 1 is there, and then 4 and 3 is there. Okay, then now again what we need to do here, again we need to compare 4 and 3. Out of 4 and 3, which is greater? 4 is greater. Now let's swap this 4 with this one. Okay, so now my 4 will go here, and then 1 here, and then 3 here. Okay, so now just change this in here as well. So here I'm going to write 4 and then 1, then 3. Okay, and here we have already inserted 10 at this position, right? So this is one more empty space. Okay, this is one more empty space. So here I'm going to insert this new removed element 5. Okay, this is done. Now we have to delete this element. Okay, this from my heap. So let me draw the diagram again. So here this is 0th index, this is 1 index, this is 2 index, this is 3 index, and this is 4 index. Okay, so after removing this 4, my heap size is going to be 2 only. Okay, this one. So now here 5 is already there, 10 is already there. Now what I need to do, I need to bring the last element from my heap. Okay, so why last element? You know na, first we insert this, then we insert this, then we insert this. Okay, so this is going to be my last now. So I am going to bring this 3 to this position. Okay, here, and my 1 will be here only, and I have removed the 4. Okay, so 4 is somewhere here. Okay, so now let's do this. So here I am bringing 3, here it is 1 only, then here this is element I need to put it here, 3 1 4 5 10. Okay, so now again, now after that again I have to remove the topmost element from my root. Okay, from my heap. Okay, so after removing this, so my heap size will be 1 only. So here it should be 3 I have to insert, then 4, then 5, and then 10, and here 1. Okay, so in the end you will find that it's already sorted. Okay, so we get the sorted array 1 3 4 5 10. Okay, so for this whole process, okay, sorting, okay, using HeapSort. Okay, I am implementing HeapSort, and then before that I am using Heapify, okay, to create the heaps, okay, and all that stuff. So what we did the sorting the array, we built the max heap, okay, all these things. So it is going to take the my time complexity as of n log n. Okay, and in this case we have of 1 space complexity. Okay, this is what we need, minimum space complexity we need. Okay, and time complexity is of n log n. So if you use any other sorting techniques like merge sort or many other sorts, okay, so you will not find this of 1 space complexity there. Okay, so we need the minimum space complexity. That is why it is good to understand this heap sort. Okay, so how we so you guys should know the differences, right? What is full binary tree, what is complete binary tree, and what is our heap. Okay, what is max heap, what is main heap. Okay, so you guys should know all these things. Okay, if I cover all these things in this video, then my video will be very lengthy. Okay, so just give a little bit brief of this full. So this is a full binary tree. Okay, because here all the nodes are filled. Okay, this one. So full simply means height, c height 0 1 and 2. So 2h plus 1 minus 1. So here height is 2, so 2 plus 1, here 3, 2 power 3 minus 1 is equal to 8 minus 1 7. So all the 7 nodes are filled, 1 2 3 4 5 6 7. So this is nothing but my full binary tree. Okay, and every full binary tree is going to be my complete binary tree. Okay, and if I just remove these 2, then it is also a complete binary tree, because all the values are filled from starting from here 1 here here and over here. Okay, so now if I have just removed this one, then it is not a complete binary tree because this value is null. Okay, that's it. So this is the difference between full, complete, and binary tree. Okay, so now let's move to the coding part. Okay, so we don't go in deep of all these concepts. Our step 1 will be build a max heap. Okay, so for that I am just going to call a method. So let's name it build max heap. Okay, and in this build max heap I am just going to pass my array nums. Okay, so I am going to create a max heap. Okay, so after building this max heap, what I need to do, so see here in this problem, first I am building the max heap now. So after building the max heap, then after it I have to do the sorting. Okay, so here I am just deleting the elements one by one and then sorting. Okay, all these steps I am doing. So my next step, okay, so this is nothing but my step 1. So here I am writing step 1, and this method is going to build the max heap for me. Now I am moving to the step 2, that is sorting the array. So what I'm going to do here, so let's run one loop for int and I is equal to here nums dot length minus 1 I should be greater than equal to 0 and I minus minus. Okay, now inside this we have to swap the root largest element with the last element. Okay, so this is what we are doing now. So this is the largest element, 10. I am swapping it with the last element. Okay, so what I'm going to do here inside this, so here let me write step 2, that is nothing but sorting the array. Okay, so inside this what we need to do, let's see. So I am going to do the swap now. So here I am just going to call one method swap, and in my swap what I'm going to do, I am going to pass my nums array, and after that I'm going to pass first element. Okay, first element is nothing but the index that I need to swap now, this one, and I need to swap it with the which element, I have to swap it with the last element. So here I'm just going to write I. Okay, I is nothing but my last element right now. Okay, so first element I am swapping it with the last. Okay, so I'm just going to call this method swap of nums 0 and I. Okay, so this is going to swap the root largest element with the last element. Then after that I have to heapify the reduced heap. Okay, so here see, after doing this we are again doing the heapify now. All this process, like this 5 is going to change with this 4, then this 4 is going to change with this 1. Okay, all these things now. After removing this 10, okay, after removing this 10 we are doing all this process. And I think I did somewhere here, okay, I think I have removed side by side. Okay, so after removing this 10, this 1 will go here, then 1 is smaller than this 5, then we did the swap. Okay, then this 1, when 1 will come here, then I have to do the swap with 4. Okay, all these things that we did. Okay, so again I have to call what I have to call heapify. Okay, so here I'm going to call one method heapify, and in my heapify, in this method we have to pass my nums array. Okay, and after that just pass the index. Okay, current index. Okay, so here I'm just going to pass 0. We have to do the heapify in the reduced part. So here this one, and here I'm just going to pass I. Okay, that's it, and that's it, and in the end I'm just going to return the nums. Okay, so now we have to define all these methods that we did. Okay, this is done. Okay, so now let's write the code for first swap. Okay, so how this swap is going to work. So let's write the code for this one. So private void swap, and in the swap I am passing my nums array, and I am passing my index I and one more index j. Okay, so now what I'm going to do, I'm going to create one temp. Okay, int temp, and in this temp I'm just going to assign nums of I value. Okay, and then after that I'm just going to change nums I with nums of j, and I'm just going to swap nums of j with the temp. Okay, that simply means nums of I value that previously we have stored in the temp. That's it. Okay, this is done. So this is for swap method. Now we are calling this build a max heap method first, so let's define that as well. So here I go, and now write private void build max heap, and inside this we are just passing my nums array now, int nums. Okay, so now in the starting when we did the max heap, so somewhere here, so first I checked for this 10 first known leaf node. I have told you first I need to check with 10, then after that I checked for this 4 later on. Okay, so only these two things that I did now. So starting from this until 0 I did. Okay, so here that is why I have derived this formula 5 divided by 2 minus 1. Okay, so now what I'm going to do inside this, I am going to write first, let's calculate the length of my nums array. Int n is equal to nums dot length. Then we have to start from the last known leaf node and heapify down. Okay, so there is one more concept, heapify. Okay, so what is heapify? So in heapify we are checking in this direction. Okay, downward direction. Like if I just select this 10, then I am going to compare the child of these two. if which one is greater, this 5 is greater, then this 5 is greater, then I have to compare this 5 with this 10. Okay, so direction is going to be downward. Okay, first 10, then I'm going to check for 4 and then 4 children. Okay, direction is going to be down, like first for this particular part. If I'm at this 10, if I'm at this 4, then I'm going to check for this part. Okay, direction is downward. Okay, this is the difference between Heapify and normal insert and in normal create and delete in the heap process. Okay, so in normal create heap process, our direction is going to be upward, but in Heapify our direction is going to be downward. Okay, so this is one more concept. Okay, I don't want to go in deep for this Heapify, but just go and see the concepts on some other websites, okay, regarding this Heapify. Okay, read about this in Google, and if you still have any question, then please do the comment. I will try to make a separate video on this concept. Okay, all these concepts, Heapify or all the things. Okay, so just add the comment if you need. So now here I'm going to write for int I is equal to n divided by 2 minus 1. Okay, and here I should be greater than equal to 0, and then I have to decrement my I, and here inside this I have to just do the Heapify. Okay, Heapify. So in Heapify, you know that we are passing nums, then we are passing I, then we are to pass this n. Okay, that's it. Okay, so now let's define this Heapify method, and that's it. Okay, we have defined all of the things. We have defined this swap, we have defined this build MaxHeap. Only this part is left out. Now let's do that. Then after that our code will be done. Okay, so here private void Heapify, and inside this just pass my nums array, int nums, int I, int n. Okay, so first we have to initialize the largest as root. Okay, so here I'm going to create one variable int largest as I. Okay, so largest is pointing to this value, that is root. Okay, so now how we calculate the left and right? So here I have shown you, right? So same formula that I'm going to implement here. Int left is equal to 2 into I plus 1, and int right is equal to 2 into I plus 2. Okay, this is done. So we have got the left child index and right child index. Now we have to check if left child is larger than root. Okay, so if my left child is larger than root, then we have to swap it with the left child. Okay, so all these things we have to check. So here I'm going to write if my left, it should be less than n only. Okay, and after that I have to check nums of left. Okay, nums of left, that simply means left child. If it is greater than nums of largest, that simply means my root. Okay, nums of largest, spelling mistake, largest. Okay, so if this is the case, then my largest will become right, largest will become left. Okay, this is done. Now same way just copy this, and we have to compare this with the right as well now. So if my right child is larger than the largest, so forth, then we have to replace that with my largest. So here I'm going to write right is less than n, and nums of right, if it is greater than nums of largest, then my largest is going to become right. Okay, so simple. And now in the end I'm just going to check if my largest is not root, then we have to swap and continue heapifying. Okay, so that's it. Just 2-3 lines of code is pending. Okay, just one if condition is pending now. If my largest is not equal to root, so simply means that it is not equal to I. Okay, because I have initialized largest equal to I initially. So if my largest is not equal to I, then what we need to do? Okay, then we have to again swap. Then we have to do the swap only now if my largest is not equal to root. So I have to swap what? I have to swap in my nums array, and I have to swap I with my largest. Okay, this is what we need to do. Spelling mistake, largest. Okay, and then after that again we have to do heapify. That's it. That's simple. That's what we are doing. Okay, now we have to do heapify on what? We have to heapify on my nums array. Now I have to check for the largest, right? Largest, and n. Okay, so this is what we are doing right every time. So see here, 4 10 5 1 3. Okay, so initially array was like this 4 10 3 5 1. Okay, so initially I checked for this 3, this 10. Okay, this place. So then after that I checked for this 4. Okay, later on. So all these things that we did step by step. Okay, so I hope that you guys are clear. Now let's run the code and see if there are any code issues. Okay, so see here's one spelling mistake. It should be x now, so that is why it is giving it is max heap. Okay, let's run it again. So now all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And now let's check the time complexity. So time complexity is going to be of n log n. This is what we need. And can we check space complexity? Okay, let's see. Yeah, space complexity is O of 1. Okay, so I hope that you guys are clear. Okay, so all this process, right, Heapify and all this, it is going to take off and log n time complexity only. Okay, all this Heapify process, MaxHeap creation, and sorting, all these things. Okay, off and log n in this code. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. And if you guys need one separate video on complete binary tree, full binary tree, Heapify, MaxHeap, min heap, so then please do the comment. Okay, if you need any specific topic, then please do the comment. I will try my best to make a video on that one. Okay, thank you. Meet you guys in the next video. Bye bye.